All right, guys, welcome back to building a robot arm. So this week we're gonna continue on with some coding here. So this week we're gonna do that, and then next week we'll get back to building again, and we're gonna finish up building the claw to attach to our robot arm. But today, some more coding, because one of the things I noticed was that our arm, even though we got it going, it was a little bit rough. The motions were a little bit too fast, so we want to be able to slow that down, and I'm going to show you how to do that effectively. All right, so this is a code that we had from last week, and I'm just going to just load this in. Let's go ahead and do that, and it should start moving, and we'll see that it's a little bit rough. Okay, you can see it kind of like the base here kind of moves as well because the top is moving so quickly. All right, so the first thing I want to do before I slow it down is add that button in. That was one of the challenge number 4 here. So I'm just going to quickly do that. I won't go all into the detail here, but we did it last week where we put in the button and we connected it to pin 2. And so let me just put that in here. So we're going to have pin mode 2 is input, and it's going to be input pull up because we want it to use the internal pull up resistor. So we don't have to add the extra resistor here. As you see, there's no resistor on the breadboard. And then we just, in our loop, we say, if digital read 2 equals low, then do something, else do something else. And then we also took the motion code and we put it into a function. So I'm going to cut that and put it into a function to make it a lot easier to read. So void, and we'll call it routine. And I'm going to paste. So our little, all that code is here. So now we just say, we can just say routine, and it'll do all of that code inside here. So going back here, digital read 2 equals low. This means when I press the button, because when I press it, the digital read, the input becomes low. So when I press the button, I want to do the routine. Else, just do nothing. All right, let's upload this. And at this point, it should only start spinning once I press the button. Okay, press the button, there. And then it should run through, go through the routine, and then stop. Okay, let's try it one more time. Press the button. Okay, so the nice thing about that is that once you have it programmed to only move when you press the button, the robot's not kind of going crazy as you're trying to code. All right, so let's slow down the motion, starting with the first motor. So the first motor is going to be the base motor down here. And so that's going to be this code right here, right? So right now it goes to min, max, and then mid. So it moves to 3 different positions. So if you remember, in order to slow it down, we need to tell it to move to a bunch of different positions that are closer together, and then that's going to make it move slower. So I'm going to take this, I'm going to copy, and I'm going to make a new routine called slow routine. Okay? And so in here is going to be our code to kind of slow things down. All right, so I'm going to take what I just copied from up here, and I'm just going to paste it here. All right, so this is the original code for moving the base motor. I'll do the other motors later, but let's just start with the base one. So I want us first go to the 0, and then, go to the minimum, wait a second, go to the max, wait a second, go to the min. So rather than just going from min to max, what I want to do is make a bunch of little moves from min all the way to max. How are we going to do that? We're going to use our for loop. All right, so I'm going to just move this down and write our new code up here, okay? Actually, I'll comment this out so it doesn't confuse us. All right, so we're not going to run this, but we want this here so we can kind of look to see what positions we want to move to. So first one is base motor min. So I'm going to do this. I'm going to say base motor min. So that's the first move. Now the second move, we want to move to a location that's close to base motor min. So how do we do that? We use our for loop. So I'm going to do for int I equals 0. So we have a variable named I, and it's an integer type. I'm going to do the semicolon, I less than, and let's see, what should this be? So what I need to do is I want it to say, I want to go from 0 to some number. Actually, I think I've already messed up. So what we need to do is right here, this 0, where the 0 is actually going to be the smallest angle that we want. So the smallest angle is not actually 0. We have these nice little variables here, right? So we should just use them. The smallest angle is base motor min. So we can say I equals base motor min. So what I'm saying is that I want to start I to be base motor min, and then I slowly want to get bigger and bigger until as long as I is less than, what's the highest, the biggest number? This one, base motor max. Base motor max. All right. Then we put a semicolon, and we say I plus plus. All right. So this is these are the parameters of our for loop. And then we say curly brace, and then a closing curly brace here. So let me put some spaces here, make sure we can read this. So let me just recap. I know that was a lot to kind of digest, so I just want to make sure we slowly go through this. So what I'm doing here is this first part right here, I'm saying I'm creating a variable called I, and at the very beginning, I want to set I to base motor min. Okay, that's the smallest angle. And then to best explain this, I jump to the third part right here, which is I plus plus. What does this mean? This means that every time I go through the loop, I want I to increase by 1. It's kind of a funny way to say that, but that's just the way that C code works, okay? So I'm saying that every time I go through the loop, I want I to increase by 1. Now, what does this part mean? This part means keep looping through until, or keep looping through as long as I is less than the base motor max, which is the max number. So I is going to keep getting bigger, bigger, and bigger until it reaches base motor max, and then that's when the looping is going to stop, because we don't want it to go past base motor max. All right, and I'm going to say it again one more time, so no worries if you didn't quite get it that first time. So right here, what do we want to do each time we loop? Well, we want to do this. We want to say base motor dot write I. So if that didn't make sense, if this part didn't really make sense the first time, it might make a little bit more sense now because I put this in. So what does this mean? Base motor dot write I. It means that I want to move the base motor to the angle I. Now what is I equal to? Now I is a variable, because I said it right here. I is a variable that keeps increasing every time it loops. All right? So the first time that it loops through, I is equal to base motor min. And then so it's going to say base motor dot write to base motor min. And then it's going to loop through again. And every time it loops through, it adds 1 to base motor min. So it's going to be base motor min plus 1 the second time. And then base motor min plus 2 the third time, and keep going. So I is going to keep getting bigger and bigger and bigger until I is no longer less than base motor max, and that's when it jumps out of the loop and then it's finished. Okay? Now I'm going to put a little print statement in here so that we can kind of see what's going on, all right? So let's go here. Let's do a serial.begin 9600, okay? And then here, we're going to say serial.println I. So as it's looping through, I'm actually going to print out what I is. And that's going to give you an idea of like what's going on. All right, so let's try this and see what happens. Oh, we got to make sure we call slow routine, right? So let's go back down here, and I'm going to change this. I don't want to do routine. I want to do slow routine. All right, so when I press the button, I want to do slow routine. Let's try this out. Okay, I got my monitor here. All right, and let's press the button. All right, so you saw that it went from 0 and really quickly all the way to 179. Let me try again. All right, so one thing you notice, it's still like kind of fast. So how can I fix that? You can't really see what's going on. You might have already been saying it in your head. Let's add a delay in there. Let's say, let's delay 100. So between each move, it's going to delay 100. I think that should be better. We should be able to see what's going on. Okay, uploaded. All right, let's try it again. Should be a lot slower, I think. Check it out. It's going angle, 1 degree at a time. So it's a lot smoother motion. All right, very nice. Now, let's see what happens if we, let's say you want it super slow. So we're gonna wait 1 second between each angle here. So I want you to kind of we're gonna look at this code here. All right. So when I press the button base motor min, let's see what base motor min is. Base motor min is actually 0, okay? and base motor max is 180, all right? So what's going to happen is the first time, going back here, the first time it loops, I equals base motor min, which is 0. Then the second time it loops through, remember I said this adds 1, right? So it's going to be 1, and then this, and then 2, and then 3, and then 4, and it's going to keep going until I is no longer less than base motor max, which is 180. So that's why at 179, which that's the last time that I is less than 180, it jumps out of the for loop, and then the motion ends. All right, so let's make sure that that's correct. So let's go to the monitor now. I think I uploaded it. Should start at 0. I'm going to press it. 0, 1, 2, 3, 4. You can see this guy. I think you can see it moving, right? 1 degree at a time. So this will take forever, right? But it's just going to keep going until it hits to 180. So I'm not going to make you watch the whole thing, okay? But I wanted to give the print statement so you can see that I is getting bigger by 1 each time as we're moving across, moving the servo motor. Okay, let me disconnect this. Going back to here, okay, I think 100 is probably too slow. I'm going to do 1,000 too slow. I'm going to put 100. Okay, so now this for loop right here, this moves base motor, and I think it's moving this way, which is counterclockwise. So let's also write for move base motor clockwise in the other way. So it's going to be very similar, it's just reversed, okay? And so I'm going to copy this and then paste this over here. All right, so what do I need to change? So to move from to counterclockwise means that I doesn't start at base motor min, I actually starts at base motor max, okay? Because this code right here, by the time it finishes, I is like 1 degree less than base motor max. So that means when I get to here, I should be at base motor max. Okay, so that's why this is base motor max here. And then, instead of getting bigger, because I want to move the other way, I'm trying to go from big to small now. So to go from big to small, I need to subtract 1. I need to get smaller by 1. So the way you do that in C code is I minus minus. All right? So now I'm subtracting 1 each time. Now I want to keep looping until 1. So it's going to start from base motor max, which is 180, and then 179, and then 178, and then 177. Keep on going until the smallest number, which is base motor min. Now everything's reversed here, so I needed to say I want to keep looping here as long as I is greater than base motor min. All right, let it sink in a little bit. I know there's a lot going on here. So we're starting at the max angle, and then we're going to be subtracting by 1 each time we loop through. And we're going to keep looping through by 1 as long as I is greater than base motor min, which is 0. All right, so let's see what happens here. All right, I'm going to upload, and we're also still printing out I. So we should be able to see it get big. This one, I will get big all the way to 179, and then this part, I will start from 180 and get small all the way to 0. All right, let's upload and see what happens. Okay. Okay, pressing the button now. All right. going, it's going. To 179, and then it should reverse. Yep, now it's going back. Back to 0. All right. I'm actually technically back to 1. So it's 1 off because 1 is the last number that is actually greater than 0. So that's why it stops at 1. All right, so we have this code now to move the base motor counterclockwise and clockwise, and then stop. So why don't we try doing it for the second motor? All right. So I'm going to go ahead and delete this because we have new challenges now. So first challenge is just do what I do, is move base motor slowly back and forth. Okay. Now let's do this one together. We're going to repeat a lot of the code. We're going to move the extend motor slowly back and forth. All right. So what I'm going to do is I'm going to like copy all of this. It should be pretty similar, if not almost exactly the same. We'll see. All right. So right here is the beginning of my base, my next motor, extend motor code. All right, so what I need to change, well, we're not moving base motor anymore. So I'm doing extend motor dot right, and then I want to move it to the extend motor min. Okay, because now we have to move it, use the soft limits for the extend motor, which are going to be these. Okay, so extend motor min. Going back to here, okay, and then here we want to move the extend motor. Well, let's see. We're not really going to be talking about clockwise and counterclockwise with the extend motor because it's kind of be moving up and down. But so we'll see which direction it moves. So what I'll do is extend motor, and then I'll fill this in later once I see which direction it moves. So here we want to say not base motor min. We want to do extend motor min. And then not base motor max, we want to do extend motor max. And then this is not base motor, it is extend motor. So what's nice when we have these variables all kind of set up, all we got to do is replace the variables, the word base with extend, right? All right, and then over here, same thing. Let's change base motor max to extend motor max, base motor min to extend motor min, and then extend motor. All right, let's see what happens. All right. All right, let's try it again here. All right, let's check out the serial monitor. Okay, pressing the button now. All right, so I got my base motor. Going to move to 180. Okay, and then now it's coming back. All right. And then now my extend. Let me turn this, you can see. Cool. So it looks like it went out first. All right, so let's go back here. So extend motor out. It first went out, and then it moved in. Cool. So now we have these two done. And you know what? I'm going to speed it up a little bit. Let's, I think we could go a little bit faster. Let's do 50. So you can kind of, a little bit more exciting, but not too fast. Let's get this going. All right, and let's press the button. All right. Not bad. Not bad. Extending out. And coming back. That's pretty good. Okay. Now the challenge 3. Would be move the lift motor slowly back and forth. All right. So what you would do is kind of do what we did earlier, is you would copy this code here and then replace what you need to replace with the lift motor. All right, so I'll let you guys do that on your own. One thing I also want to do here, kind of play with before I sign off, is I want to be able to control the speed. So one thing you realize is that you might have seen is that if I change this number, this delay, it changes the speed. Okay. So if you look at here, I have 50 here, 50 here, 50 here. I use it all over the place. And so what I can do is put a variable there, and then I can use that variable to control the speed. So why don't I do something like this? I'm going to go up here. I'm going to call this speed. All right, int speed, and I'll just set it at 0 for now. All right. So what I can do is everywhere where it says 50 for my delay, I'm going to put speed in here. Speed, I think, is that it? 1, 2, 3, and 4. Okay. So if I put 0, it's going to be a lot faster, like super fast. And so why don't I do this? Why don't I change the speed depending on whether or not I press the button? How about that? All right, so let's look at my loop code here. So I could do something like this. If I press the button, I'm going to say speed equals 50. So it's kind of slow. Okay, and I'll do the slow routine. But if I don't press the button, I still want to do the slow routine, but I want to make my speed equals, let's make it 0, so it'll be faster. So if I don't press the button, the slow routine is going to be faster. if I press the button, slow routine is going to be slower because speed is going to be 50 in that situation. I think that should work. Let's see if this actually works. Okay, so now if I don't press the button, it should jump down to here and just start moving at speed with 0. Yeah, okay. That's kind of cool too. All right, so now if I press the button one time, it should start doing slow stuff. Okay, now I press the button, nothing happens, and we talked about this a little bit at the end of last class. If I press the button, but it's still doing this routine, it's not going to catch it. So what I need to do is keep holding down the button until it finishes the routine. There, so let me keep holding it. There. So it's like the code's not perfect because it will only detect the button press if it's right here on line 112. And that's the problem with the code. But it's okay for now. So that's why you got to hold it down. All right, so now it's going to finish this. Once it finishes this, then it's going to jump down to here and then go fast again. Now let's try again. So hold it. There, it got there. All right. So challenge number 4 is move fast or slow based on button press. All right, and that's kind of just what we did right here. Now, here's another thing, something like extra credit. This one's pretty tough, so no worries if you don't get there, but you could think about getting this to work. So cause motors to move fast or slow right when you press the button, rather so that you don't need to wait, right? Because right now you have to wait for it to finish the routine and then it'll go. How can you make it so that right when you press, it starts going slow no matter what? So just be more specific, cause motors to move slowly right when you press the button so that you don't need to wait. How would you do that? So that's something I want you to think about. We'll talk about it more in class when we meet. Okay, so that's kind of like a little code brain teaser there. All right, that's it for today. Have fun, good luck, and talk to you guys soon.